they could orchestrate that. So to me, like that wouldn't really confirm anything about their model in a way. But I understand for those arguments for you would be compelling, or you said they are compelling to you. But I'm just saying, can you also see why they might not be on the other hand? Because I mean, with the amount of money that the government military has, they could definitely have lights in the sky doing things, to copy their, like a magic show would
Honestly,
in that way.
Gio, come on. You really think that's possible for the government to hide the shit?
Yeah, of course. If they're going to do the whole like Artemis, kind of hoax type thing, they would definitely put a light that someone on the ground who's a civilian would be able to check it, because that would be part of the whole thing to convince them that it confirms the globe in some way, even though they're just putting that light artificially.
And don't you think millions of people would be checking that and confirming that, wait a minute, that light's not doing what it's supposed to be doing? That light's not as far as
they make it match the story they're telling, the physics that they're claiming. Therefore,
how would they just make it match?
Someone on the ground could buy a telescope and do it and then think they're confirming it. But meanwhile, it's just the government military complex putting it up there.
It would be a little bit complicated than that, because the idea is that you would have to do more than just put a light in the sky that is observable to a telescope. It would also have to be observable at the correct angles, thus the problem of parallax comes out. Because when Astronomy Live was able to measure the distance to the Artemis spacecraft, the Orion spacecraft, he did this show, then they would have the technology to do it for real. There would be no reason for real. There would be no reason. There would be no reason for them to brute force to a conspiracy. That'd be like someone saying, "Hey, we should fake the footage of the fake moon mission on the moon." It wouldn't make any sense to do it that way, considering that the main cost of the whole operation is the massive rocket, which you would have to build anyway.
Well, it's funny. I said I wasn't going to debate, but now I almost went into that because I had mentioned what I was really going to ask you is what of the primary knowledge or first order measurement type things that you've done. That's why I jumped to this observation of the Artemis, because I know that's
what's the most convincing?
ISS, etc. That was really the original question, but then I kind of went into it because I brought that one up, and then B-Ball jumped in, and then I got sort of debating him or whatever a little bit. But that's fine. We don't have to go into that style. But either way, well, that was going to be my question. I know one of them is your Artemis footage and the ISS. That's why I mentioned those observations of those things. And when I mentioned the magic show part, I wasn't really referring to like Saturn necessarily. I think Saturn is actually part of the quintessence of the ether at the high levels of this realm. So those are real things. Those are not like some government planted things. There is actually some people have a theory of that the planets were like, but anyways, leaving that aside, I think those are like part of nature. But these things, the Artemis, the other like quote unquote satellite, the lights that are blinking and things like that, the idea would just be that it's all happening in a much more local environment, at least local compared to like hundreds of thousands of miles, like not that far, all within, let's just say 10,000 miles, just to leave a big range, like more like something like that local, to where they would just have to simulate the positions of things to then match the model that they're claiming is actually happening of things orbiting around a sphere. So that's more what I'm referring to. It's just that it wouldn't actually be going 236,000 miles around the moon or whatever. They would just simulate the light, in the sky for observers to be able to see it. So I mean, that was kind of more the idea.
Well, I think what you were asking me was, what work have I done myself that was the most convincing of my position?
Of primary, yeah, because couldn't it always have an assumption ultimately?
Well, that's the whole idea of doing repeat observations with better, more clearly defined goals, is that you get rid of as many assumptions as possible. And so when we measured the distance to the sun, it was imperative that we don't just take, for example, Kepler's third law on by faith. We had to actually verify that in order for it to be utilized within our measurements. So we said, okay, since Kepler's third law is an intrinsic part of the process, we need to verify that on our own. And so if you go through the entirety of the explanation and the measurements and everything like that, it's all our own work, except for two pieces of information that can be independently verified. And those two pieces of information is the historical data going back to the 1950s and the angular size, largest at opposition and smallest at opposition. But those two secondary ones, the opposition angular size thing, is going to be this year or next year in February 2027 is the smallest size that it's going to be seen. And then in 2035.
As what? The moon or sun or what?
No. The angular size, is going to be like 26 arc seconds wide at its closest point during opposition, and only 14 arc seconds wide at its furthest point during opposition. So we found examples of that from amateur astronomers that had nothing to do with any government agency. They just do this shit for fun, like me and Astronomy Live. So we took their data.
The angular size of what?
Mars.
Oh, okay, Mars. Okay, sorry.
So we took their data and we implemented it into our measurements. So you could say that we're taking their word for it. That was an assumption that they're telling us the truth and they're not just full of shit. But we will be able to close that gap at least by 2035. And if I were a betting man, I'd be betting that they were telling the truth when they took their measurements. So when it comes to other things, like, for example, measuring the distance to Mars and the angular size of Mars and then the actual size of Mars, that was all our own work. No assumptions whatsoever were utilized when making that determination. The altitude, size, and speed of the International Space Station, no assumptions were made when making that determination. Angular size of the sun and how it doesn't change throughout the day, no assumptions were made during that determination, and so on and so forth.
Yeah, those are like, I mean, what were you referring to, the angular size? would be that like circular region in the sky that what they're calling the planet or the sun or the moon takes up. So yeah, that's like an astronomical kinematic just reality. Now, to the best of your ability to measure it, obviously, and obviously refraction or scintillation or other should all be considered. But no, I agree. That's just like the kinematic actual astronomical specifics of the degree of what it's actually taking up in the sky. So yeah, that part doesn't have any theories.
That can be
getting
out by a single observer.
But then that has to be extrapolated into a larger theory though of a heliocentric type model.
No, it doesn't. It's its own thing. It has its own merits in which it can stand on, regardless if the heliocentric model is true or if the geocentric model is true. Angular size is its own thing that has no bearing on any sort of particular orbital model that you wish to assume for the sake of argument.
No, I know,
Parallax also doesn't care.
The positioning is just the actual kinematics of it. And I agree that those are not related, but I'm saying if someone's going to take those angular size changes though and then apply some kind of ratio to it and then claim that shows that they are, that Mars and the oppositions, like you said, when it's through the idea of it orbiting around the sun, then you do have to extrapolate some concepts to take it to that, is what I'm saying, the angular size, because that's what you were alluding to the primary first order type of observation, right?
We were talking about just distance at the time of measurement and its actual size at the time of measurement, not its orbit. Its orbit was determined via Kepler's third law, which was also independently verified because we were using satellites around the Earth to stress test Kepler's third law to see if it actually turned out to be the case. And when we tested Kepler's third law, which depends on Newton's ideas to be coherent, then it worked. It passed the test. And so when we utilize Kepler's third law in this particular scenario, the only thing that would make sense without any contradictions whatsoever is if the sun is in the middle.
Well, but I mean, it can all be viewed as geocentric and it's equivalent. But I mean, are you saying there's some way that you feel like it's exclusive? That
it is exclusive because
what is the exclusivity idea there that you have?
I appreciate you asking that question. The exclusivity is the idea that contradictory entities or models do not exist. And where's the contradiction? If you were to place the Earth at the center of the universe, and Kepler's third law was deemed to be the way things work, as we were able to independently demonstrate, then it states that if an object is further away from a particular central body that it's orbiting, then it will orbit at a particular rate that there's a relationship between the distance and its orbital period. Geocentrism, however, requires everything to orbit around us within roughly the same amount of time. But that would require Earth to be many different masses, all at the exact same time, dependent on the position of multiple different altitudes. Now, obviously, a thing can't be one thing and another thing, i.e. it can't be one mass and a different mass at the exact same time. That's a contradiction. So therefore, the entire geocentric concept is based on a contradiction.
Boom. I only came at the end there, but I appreciate that.
I believe Cool Hard Logic made a video about that particular problem with geocentrism before, but it is what it is.
Wait, sorry, I was like listening, but I was kind of away for a second. Would you mind repeating that? You're talking about Kepler's third law, and then this is something that are you talking about geocentrism, like a globe centered, or what are you referring to?
Well, I think that's what we mean when we say geocentric. Geocentric is it's not the Earth that moves around the sun; it's everything else that moves around the Earth. Isn't that what geocentrism is?
Well, globe geocentrism, yeah.
I don't think flat earthers would call themselves geocentrists. They would just call themselves flat earthers, would they not?
No, because the word flat earther is just kind of some modern, seems like probably the CIA, FBI had something to do with that, kind of putting that into as like a meme almost. Because I mean, what humans would have always had since the dawn of time before the globe was basically like a 3-layered world in a sense. Now, whether the whole thing is encompassed in a sphere or it's infinite, that's like for maybe metaphysical, spiritual idea. But that there is 3 layers. You have the upper world or the heavens, the celestials, etc. You have the physical plane of existence that we live on. Then you have essentially the underworld or under the earth, deep in the oceans.
And we were talking about different things then. So you weren't talking about geocentrism in the classical sense.
Well, I mean, there's the globe geocentrism idea, but then I think just even before the globe, like geocentrism would just be interpreted as the Earth is in the center. I mean, it's sort of like if you have a hamburger, you got the bun on the top, that's like the heavens, you got the meat, that's the Earth, the bun on the bottom is like the underworld. But it would, so geocentric, like Earth-centric would be the Earth is at the center, hung between, the upper heavens and the underworld or whatever you would call it, or the depths below us.
So not geocentric in the classical sense, as in everything goes around Earth, but geocentric in the sense that if we're talking like reality is a hamburger, as you so eloquently put it, we would be the patty.
Well, it's just a 3-layered, like all the ancient like shamanic cosmologies.
Well, besides making me really, really fucking hungry, that would be a model that would be something that all I could say was it wasn't detected within our measurements, because in order for such a thing to be the case, then that would also have to be the case for not just what we observe above our head, but how we observe it, how we measure it. So if I'm looking at a particular star in a particular direction, like the North Celestial Pole, for example, the angle at which I see it would have to be consistent with a flat surface, and we don't see that. Because even in that particular model, the hamburger model that you're bringing up, we would expect to see 2 things. 1, the altitude of the North Celestial Pole would be consistent with a flat surface, and 2, we would see large circular angular size shifts between different latitudes. And we don't see that. Regardless what latitude you're on, the circle of Polaris, for example, is always going to be the same angular diameter, regardless where you are on Earth. And in the flat Earth hamburger patty model, that would not be the case. The circles would actually change in diameters.
Well, I'm not okay. So first of all, in terms of the hamburger kind of idea, that was just like a visual kind of idea. But if you have like an upper world and a lower world, and then the earthly plane, the sky, I'm not referring to Polaris being at like the center of like the idea of like the cosmic egg or like a planisphere where you have a plane in the center of a sphere. So if the plane's in the center of a sphere and you're looking up at like, let's say the upper hemispherical part of it, now that may or may not be happening on a much larger scale, but I'm not referring to some idea that like Polaris is just at the center of that and it's just some radial thing like that. I think the sky is like a toroidal sky. Like it's a double toroid. It's all above us and it manifests the way it manifests and we're on a planar surface. So like whatever the shape of the whole hamburger top would be or whatever, like in the hamburger idea, whatever the shape, like the two poles are in that. Is what I'm suggesting. The two poles are in that, whatever that, if it is a larger dome or if it's infinite, like let's either one. But whatever that is just that larger question. But the two poles that we see in the equatorial stars would all be seen from that plane, from like in the hamburger patty idea, from the plane looking up. The two poles.
I guess the question I would have is, after coming up with a particular concept and a particular, let's say, a model of reality that you believe may be closer to the truth, how would you go about testing it, or how would you recommend other people go about testing your model, your hypothesis for the way things would be? If I brought my equipment out with me, what measurement would that equipment have to make in order to either confirm what you're saying or to refute what you're saying?
Yeah, that's a very good question. And I realize the whole scientific paradigm is very strong. And although I do think they're wrong about the shape, I also, realize that it's a whole system that you'd have to prove it, basically is what I'm saying. Like it'd have to be proven. So that's a huge question. I mean, there's a whole bunch of curvature tests, Earth measurement tests that need to be done, additional work with gyroscopes. If that's kind of what you're starting to, in terms of actually validating this, like if we're talking about Earth is a plane and the sky is a two-pole system above us, then the scientific paradigm obviously sees it very, very differently. And so if you're asking like what evidence or what tests or what measurements would have to be done to actually shift the whole paradigm to this being the truth, is that what you're saying? Or
yeah, what would you, so if you put forward a particular model and I said, okay, I'm willing to gather evidence out there in reality, what tests would you want me to do? And what measurements would be outside the realm of your model? So for example, if your model made a particular prediction and I got a particular measurement, how would you know that the measurements either agreed or disagreed with your particular model?
Yeah, so there's a bunch of angles. First of all, there's like tangible physical curvature tests of water and of land. There's all that category. And then there's the whole, so there's that entire category. Even replicating something like LIGO to get a straight material to compare to the curvature of Earth, let's say, that is allegedly there. So like there's that whole family of tests. There's all the distance tests, like distance alone can do it. If you have 4 points, for example, that are large enough and you measure. Now, my issue there is we need to do tangible measurements though on the ground. Or, I mean, there's like LiDAR and other technologies I'm obviously open to using, but we can't, like, I'm not saying just going off of Google, but actually measuring ground distances, because distances alone will determine, especially if you have like 4 points, let's say, that are far enough apart, it'll determine whether the surface is planar, or whether it's spherical. And then in addition to that, there's the whole category of doing angles to stars and then plotting GPs on the ground and then drawing circles of equal altitude and then literally doing hundreds, if not even thousands of those. And as you do all those angles to all those stars and all those circles of equal altitude, that's another way to do it. And the distances are involved in that. That's why I bring it in here, because when you have the GPs and circles of equal altitude, hundreds of them or even thousands, this is how they used to map, and this is how you map the Earth with the sky. But once you get all those angles, all those circles of equal altitude are either going to be coplanar or they're going to actually fit around a sphere. So that will do it too. And then the distances are linked to that because you have the distances that are all between the GPs, which will also be coplanar distances or spherical. So this actually could all be done in the real world. It's all like at our fingertips to do, once the time is ready for that to happen. But those are just two categories. I could go on and on, but I'll pass the mic because I said a lot there. But those are some of the whole categories of it.
Okay, so you were saying primarily it would be ground measurements. Basically, you would want some sort of measurement of the ground, and I'm assuming visual stuff would not be sufficient for you personally. Am I correct in saying that?
Well, I think visual is very useful and is a great conversation and is a great thing to have, and we should keep doing as much as we can, I think, in that whole world, just as a human race, of the optics. But ultimately, if we're going to change the whole paradigm that the Earth isn't actually a sphere, I realize what we're up against just in terms of the mainstream structure and everything going on, let alone the financial, governmental, military, it's all connected. So yeah, I mean, we've always talked about doing having a tangible measurement. Yeah, something that is physical, tangible, that you can touch, even have it as like a monument where people could come visit. So like scientists from all around the world who are interested could actually come, touch it, they could bring their tools, they could do whatever they want to verify it, a tangible measurement. And whether that's compared with standing water or with the ground, either way, something like that, where people could come and actually observe it themselves. And at that point, it would only be a matter of time. I mean, if it did tangibly show that the Earth isn't curving, but then you'd have to have several of them around the world. But I mean, that's one whole angle of it. But yeah, having it be tangible, I think, is going to be required in my viewpoint. I don't think optics are going to do. I mean, there'll be more that it can happen, but it's not going to shift the whole paradigm.
So if I were to present to you optical measurements and angles and stuff like that, and theodolites and stuff with telescopes, for you personally, is it safe to say, is it fair to say that would never, ever be enough?
No, not necessarily, because I make arguments about plane surveying and how accurate plane surveying is, like within a couple millimeters, within a mile, for example, and you totally should be able to measure 8 inches with that, but they don't. They treat 100 square miles as planar. That's like generally about 100 square miles is, so that would be like a 10 by 10 mile square, for example, is all plane surveying. So I actually make arguments and I talk about ideas around that with plane surveying. So no, I do think plane surveying is effective, and it works with rise over run slope. That's all planar as well. And if the Earth was a sphere within 100 square miles, you would definitely have to incorporate for the curvature. So I don't think all optics are out. No, I think they can be accurate. But if we're talking about something that's going to change the whole paradigm, because the globe has this whole refraction kind of assumption, in my viewpoint, that they always apply to it. So it's just sort of like an impenetrable, at least for the paradigm, they set up a good defense system with that.
Well, let's put it this way. As we know, if we take a flat piece of paper and we draw a triangle on it, it doesn't matter how fucked up you make that triangle, as long as the edges are straight, that is, you are going to have interior angles that equal 180 degrees. So given that our line of sight is literally a line by definition, and if we have a big enough area in which we can have like 3 observers all looking at each other with the ability to take optical angle measurements, if we do that, and it turns out that we get more than 180 degrees, which is what would be expected on a curved surface, would that be sufficient? Because we have access to telescopes that can tell you literally the exact azimuth in which you are looking. So if you measure the azimuth between one person, yield off into the distance, and another person, yield off into the distance, and they were to do the same thing to you all the way around that triangle, and when you compared notes, the angles got more than 180 degrees, which would indicate a curve, would that be sufficient for you?
Yeah, so I mean, with spherical excess, this is like another family of optics or another category, because like with plane surveying, you might be doing like much shorter stretches and so on and so forth, and doing backsights and foresights and so on. But with if we're not talking about like longer distance spherical excess measurements from like mountaintops, yeah, that is definitely another category. I do think like I mentioned the 4 points and distances, and then you link like a rectangle, and then you link the 4 points on the inside with 2 straight lines, and then all those distances. I know you've seen that, obviously, and that's a good way to do distances. But the 3 points is more the spherical excess one. And yeah, I actually have a couple of test ideas. One of them involves building physical triangles on the ground and making larger and larger ones, to where you keep measuring physically off the last one. So you make like one small. This has been my idea for years, and I'm just open about it, because if anyone wants to do it, it'd be amazing. I just think it's a great idea, and someday we will do it. But like to have like a triangle that you start with, that you measure as a perfect triangle, and then you actually and then you measure from that first triangle as like the model of it. You then, with very precise tools, you make a larger physical triangle, and then from the next one you make a larger, and you keep doing that, and you do it all with tools, every laser levels, everything you want to use to try to get as perfectly as you can. And eventually, if the Earth was a sphere, like those physical triangles would actually start to deviate, like you said, the angles. It starts to like bow out. So yeah, I do think spherical excess could show one or the other. The optical for mountaintops, though, I do have some concerns with that in terms of refraction. And I do think the realm we're in, like the medium, the ether, and the sky have spherical components, but the ground is planar. So there are spherical effects to refraction.
Well, let me show you this. So here you can see this fucking loser on top of this hill right here. And if I were to spin this 360,
hold on, I'm not in there yet. Hold on, I'm gonna share it on the live stream too, so people can see. So hold on one second.
All right, let me know when you're ready. A beautiful sight. So I'm seeing here that there's a lot of mountain peaks in which we can choose from, and if we have an individual on this mountain peak way off into the distance and this mountain peak way off into the distance, it seems that we would have a lot of surface area within that triangle. And so if we were to measure the angle of an observer here, and we were to measure the angle of the observer here, and they were to do the exact same thing to the other observers, and he was to do the exact same thing to you and this guy over here, thus getting 3 measurements from each corner of that triangle, and it comes out to more than 108 degrees, given the vast distances involved. Would that be sufficient for you? And if it is, do you want to actually do it? Because I would be willing to fund your trip out to this area. I would let you use my equipment. Of course, we would test it to make sure that the angles are accurate, so there's no funny business going on. I would teach you how to use it and how to get measurements off of it, that kind of thing. And if we were to actually do this, and it turns out that the angles are more than 180 degrees, thus indicating a sphere, would you be comfortable in saying that of the evidence that has been presented to you, it is more likely, at the very least, that the Earth is spherical in nature?
Well, I mean, I would say like I'm aware of basically like probably every argument that's been put forth on the globe, so I'm definitely like fully familiar with this one. And I definitely think that like long range optics and trying to do spherical excess over long distances is problematic. For me, it really would not be definitive or exclusive of the shape of the Earth ultimately. with optics over that long of a distance. I do think, like I said, there is like a spherical kind of like, just to put it simply, almost like a bending and warping of space-time. I was going to say something else and then I thought of that. No, but there is like a warping that can affect in the medium of like the direction of light, obviously just due to conditions and so on. So, and the way the sky is almost looks like a bubble. It looks like a hemispherical bubble in a way. So like the way that the sky works, and the medium itself as well, like the medium, like the atmosphere, let's say, and obviously the way the sky does as well, have those effects. So I think that they're definitely interesting. I mean, we've gone over like the arc of the parallel, like that huge, like multiple thousands of page document. We've gone over that in detail. There's really like no actual measurements in there. They're all like weighted averages. And the other ones I've seen are weighted averages too. I also am aware though of some that claim to be done and are giving the spherical excess effect. Yeah. So I'm aware of those. To me, they're not really conclusive or definitive though, like in terms of tangibly proving that the Earth is actually curving. But I mean, I'm willing to also give like just a good faith, kind of a good faith, like mild concession to say that it potentially is a strong argument for it, because I think it's actually the atmosphere doing it, but then that's extrapolated into an assumption of the ground. But if one is trying to go that route, there are some optics that at times can match a refractive value of what a globe would be.
Well, the way that we would get around that problem is to not only make these measurements multiple times within the same day, but we would also make this measurement over multiple days. So like, let's say if I were to spend even more of my own money and say, okay, not only are we going to make this measurement, we're going to make this measurement 3 times a day for an entire week. Or better yet, we're going to make this measurement 3 times a day for 2 weeks. And we're going to get endless amounts of data out of this shit. We're going to be in data heaven. And after we get all the information, after we collect all the data, we find that not one measurement made on any of the time frames, not on any of the days, not one of it has been less than 180 degrees or right at 180 degrees. All of it has been more than 180 degrees. And we did this over multiple days and multiple times during those days. Yada, 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 you get the idea. Would that then be enough?
It would never be enough days. That's the problem, right? If you say you do it for 2 weeks, they'll say, well, why didn't you do it for a month?
All right, let me post this one. Well, no, okay. A few responses to that. First of all, okay, atmospheric conditions. I have 2 images. So the first one, real quick, I just want to say this. There is a phenomenon that some atmospherical conditions, they seem very consistent within a certain area, like more frequently than other areas. Some areas change a lot. So for example, just real quick, I'm going to post 2 images in the chat. This one in the live stream text. This one shows like the Blackpool Tower and the mountains behind it. This one seems to be pretty consistent, that it often is like this. That's why, like, this is the whole Ranty thing, when Ranty like claimed that he flipped or whatever. You were, I know, around then, and what was going on these Discord servers was wild back then and all that. But this was like the picture that flipped him or whatever, the one I just posted. Because basically the mountain, in a nutshell, the mountains behind, the snow mountains, the fact that they're appearing lower than Blackpool Tower doesn't fit planar trig. So they claim that, and it close, within a range fits what would be the globe, like if it was curving around. But here's the issue. This is not the case all over the Earth. Like the curve, the claimed like, oh, that's lower, therefore it's the globe. Because there's the one that Zanuck always brings in too, with the mountains that are smaller in the distance, and he's trying to claim it's links to the Earth curve. But there's many other observations where it doesn't match, meaning that the White Mountains would actually match the planar trig. So that's one of the issues with that. And the thing is, in certain areas, it's more consistent that the effect can be had, like if there is a warping effect, whereas other areas, it changes a lot. Like there's other places where, where other places where like that mountain and the Blackpool Tower would change dramatically on different days, different weeks, but other places it's more stable. So anyways, that brings some of those points up in terms of like the repeated ones. But but of course, repeated is good. And then there was a whole second part, but I'll let you respond.
Let me try to answer that then. Okay, new plan then. Let's adjust our plan. Let's say I were to spend even more of my own money, and instead of just going to the Colorado mountains and staying there for a week and making 3 measurements a day, we do that twice. Once in Colorado and once in, like, I don't know, North Carolina with the Appalachian Mountains. So we find three peaks of about the same distance apart as what we were doing in Colorado. The Appalachian Mountains are fucking massive and vast, and there's plenty of peaks to choose from. And we were to do the same thing over there on the other side of the country, which would be stay there for a week, make 3 measurements a day, collect the data, that kind of thing. And if both locations, after everything is said and done, both locations show a consistent value over 180 degrees, at that point, would it then be sufficient enough for you to say that it's more likely that the Earth is a sphere?
I'm sorry, dude. Could you repeat that? Or just I did hear it, but then I think I missed part of it. Sorry.
Okay. So what part? I'll just say the whole thing. Okay. So we will adjust our plans. So keys. where the angles were less than 180 degrees, would you then say it was sufficient to show that the Earth is round?
Well, the thing is, not necessarily, because you're getting to like the extents of how far you can see at that point. If you're trying to point it like as far as you can, I mean, how many miles are you talking between the? By the way, let me post this real quick here, just in the chat. Okay, this one here, I was looking for this image, which is partially why I didn't follow fully what you were saying about the different locations, but I hear what you're saying though. Let me just, okay, I posted this real quick. This is basically the claim, and it's more or less the claim you're making. This is an image I saved. It's a good one because somebody, I think, I don't know if Ruhif made this. Maybe he did, actually. It kind of looks like a Ruhif thing here. But really, he just pulled this from this 1927 datum triangulation in Utah. And if you look at the website there, .gov, all that, obviously. But this is like an official, like this is called the triangulation in Utah. So like the arc of the parallel is the one that we've gone through, and we've gone through all these, but this is another one. This is later because the arc of the parallel is earlier. This one's 1927 is claimed. So yeah, these angles right here, like, I mean, Jeremy often says that there's like no actual measurements, but this is claimed to be. Or, well, actually, I'd have to double check if this one's also weighted averages, the triangulation in Utah. Does anyone know offhand whether? But anyways, this little GIF here shows like what was claimed to be measured, and these don't. Yeah, I guess I would have to double check if this one's weighted averages as well. But nonetheless, this is the claim, right? I mean, this is essentially what you're claiming.
Well, it's not. Well, I'm not making a claim. What I'm proposing is an observation and a hypothetical. So on the hypothetical that we do this, on the hypothetical that you have the equipment and you trust the equipment, and we get the values, and they end up being more than 180 degrees every single time we do it. And we did it in the Rockies, we did it in the Appalachian Mountains. You know, two different sides of the country over a week, 3 measurements a day, that kind of thing, really dialing it in and making sure that we weren't dealing with atmospheric fuckery in any way, shape, or form. Would that be enough for you? And based on what I'm hearing, it's like, not really. Even if we did all of this, and even if I spent the money, flew you out there, and we did the measurements, and the data was, to any reasonable person, pretty fucking conclusive, it just wouldn't be enough for you. That's what I'm hearing.
Well, the thing is, if you're okay, we're talking about optics from like mountaintops over very long distances. So this is a particular phenomenon. Like some of these other optics we're talking about, like plane surveying or something that's shorter distance, or maybe other like laser tests. There's all kinds of other things, but this particular one, if we're talking these long range distances, like I think doing the spherical excess triangle is a really good test. The way I thought about it is that we would have to set up like, on land that you own, ideally, a massive triangle, basically. Then between those 3 points on that land, you could do a bunch of tests. You could do optical ones. You could try to measure the physical distance on the ground. You could even like build like a moat of water. And then you could also link that with like curvature of water tests. You use like lasers. I've had all these ideas of how to do it. But nonetheless, you have 3 points and you can do a bunch of things. You can use laser rangefinders, use LiDAR. You can do drones, like different tests with drones. You can do optics and so on, to, and have one massive triangle. And then that also could be like a monument type site that people could come visit and actually see and confirm things themselves as well, and like see the test done. So anyways, I think the whole triangle thing is it can be a very good way to establish the shape of the Earth. But this one, where you're like only doing optics from high altitude, or somewhat higher altitude over very long distances, I do think is problematic, because there are these like dropping and raising effects that happen. So like, for example, this image I'm posting right now in the chat, that it says atmospheric magnification, the one I just posted. Now, I'm not really referring to this as being like the atmospheric magnification part, but nonetheless, it's the same location, same elevation, but just different days. And see how that the oil rigs are obviously at different distances, but the picture on the right, the oil rig is like almost equal with the like height-wise with the one on the left. But the picture on the left, the oil rig is way sunken down. So like if something is sunken down like that further, like we're talking about, which is essentially what the spherical excess optically from high mountain types over long distances is a dropping effect. And so the fact that just on different days we see this on the ground level happening dramatically indicates that that's not necessarily a way to isolate the curvature of the Earth just based on that alone, of that drop effect. There would need to be more incorporated to understand what is actually occurring there. If it can be flat on one day and curved on another, basically, that's strange. Whereas like that Blackpool Tower one is pretty consistent. It doesn't move around, even though the mountains are behind the tower. And in this case, one oil rig's behind another. So yeah, so if you see what I mean, if you're doing like optical, long range with spherical excess and trying to have that be definitive, if that dropping effect's happening, one could interpret that as that the ground is curving, but it actually would just be these optics that we know happen.
Well, we wouldn't be measuring the altitude. We would only be measuring the azimuth. So whether the mountain is higher or lower in your optical train, that actually wouldn't matter when it comes to the azimuth measurement, since that would be the only thing that we would actually care about, not the altitude. So let's imagine you're pointed at a particular object at a particular azimuth, and you had to raise the telescope up in order to see that object again. The azimuth would not change. The altitude would change, but the azimuth wouldn't. So
no, I know, and I know that's what it is. I mean, it's an optical drop effect, but it ends up resulting in an azimuth distance that's larger than 180.
An azimuth being
a horizontal angle. I know it's a horizontal angle, but the drop effect is ultimately what's causing it.
No. A drop would be up and down. If we were dealing with just the azimuth measurements, that would be left and right. And the way that we would isolate and making sure that there's no fuckery is that we would be making the measurements multiple times a day. And to make sure that the location wasn't the one fucking up, we would go literally to the other side of the country and do it again. In fact, I could spend even more of my own money, and we can go all the way to Canada. Canada's got a fuck ton of mountains up there. So we can go to the deserts of Nevada. We can go to the lush forests of the Appalachian Mountains. We can go to the wintry wasteland that is Canada. We can do this in 2 different countries in multiple different climates and multiple different areas and that kind of thing. But let's hypothetically say I did all that and I paid for all of those plane tickets and really hurt my bank account in the process. And no matter what we did, we just couldn't get the goddamn angles to be 180 degrees or less. They were always over 180 degrees. Damn it. Would it then, at that point in time, be enough for you to say that, yes, we now have evidence to show that the Earth is round? And let me just cut to the chase. I'm trying to ask you, what would it take? How many of these measurements would I have to plan and trip for, and we would have to go to, and what conditions, how many conditions, like, when is it enough, or is it ever going to be enough?
I can tell you. If Geo said there's atmospheric magnification happening, that would make the thing look bigger and the angle would be bigger. None of this is tangible. You need something tangible to show that that's what's happening. This optical shit is for the birds.
So they're not interested in buying a globe, Brett. They're not interested in buying a globe, bro.
No, I think the optics are still cool and useful. Because Rez, I think like what actually does occur is like in that image I posted earlier. I'm just gonna post it one more time right here. Okay, I just posted it again. So it's like these objects can rise and fall, and then the thing is that is linked to spherical excess in terms of like this right here, this image, which you may have seen this, but it just shows how the azimuth angle is different based on basically that drop or non-drop effect. So I do think it's related to drop, although I do understand what you're saying about that it is a horizontal angle as well, and that could be broken apart. But I guess like to answer your ultimate question though, I mean we can continue on this, but because you haven't I would say that to me, I don't think this is definitive because the angles that, from my understanding, when this is done, is that they really vary. Sometimes they're a little more than 180, sometimes they're less, sometimes they're more, sometimes they're less. That's why, like the arc of the parallel, they did this massive like averaging, but they never actually gave the independent measurements. Some of these other ones, like may claim or list more that they claim were direct measurements. We'd have to like find that deeper. I don't know. I was going to double check that triangulation in Utah one, but I mean, I think when Jeremy says that, I don't think that's really been defeated yet, that there isn't really any singular measurement of spherical excess. It's all like averages and so on, because these effects I'm showing, lastly, these effects I'm showing with the oil rigs up and down, mountains and all mountains up and down. My point is that those positions change. We know those change even on a day-to-day basis. So to try to determine like a shape of an Earth linked to that, anything related to that effect could be problematic. But yeah, go ahead.
Can I respond to the...
But it's okay when you guys use it. We see too far observations. Oh, but those are okay, right? When it comes to optics?
Well, I would say those are different because one of them is a position change, which can happen. We know like in water, like you can, like the fish can look like it's over there, even though it's over there. Like we know that like displacement, but the curvature affecting, you guys are more requesting in some way that the Earth has to like sometimes have like a curve that matches a globe. And then other times it's like extended out, like a magic carpet that just extends out like an extended plane. So that's not really the same as just changing position. You're actually showing more land that shouldn't even be visible.
So what would it look like if it was curved, Geo?
Can I just reply to the image that you sent, Geo? Because it's the image that you showed in the live chat where it has the so you have the red angle, then you have the green angle, and how angle A is larger than angle B. Well, the only way that angle B would show up as larger with our telescope equipment is to literally change the pivot of the azimuth angle. We're not going to be doing that at all. So if you look at the red angle, represented by the red band, let's call it, that would be like our azimuth being at level. But then the green, we would have to literally tip the entire tripod that is affixed to the telescope mount in order to get that to change. We won't be doing that. Everything would be
that's what's claimed
every single time. So if we did that and we got angles that were actually more than 180 degrees, then would it be enough for you? I think I got the answer to this question. It seems like even though it would be valid and sound and logical, mathematically consistent, all that good shit, it still wouldn't be enough for you. So I could not take you to enough.
Nobody ever said it was sound.
Yeah, I know. I didn't say a lot of that, but that's okay. I mean, I'm not saying you're trying to bad faith represent me, but it's just maybe not quite what I would say. But let me jump in. So I wanted to try to jump in quickly before to say that okay, I know you're not tilting necessarily like the telescope or anything like that.
The azimuth.
Yeah, well, the actual like vertical tilt of it. But the thing is that between the red and the green in that image, but the claim is on the globe Earth that you are actually tilted back from it in a way where your orientation is not all coplanar. Your orientation is actually tilted because you're 100, 80 miles, 50 miles, whatever the distance is. That there is actually a very slight, tilt of level basically compared to the other point, to where you get this effect. So, I mean, dude, what I'm saying is that it happens, and then lastly, like, well, it happens in different. Like I'm explaining with like my understanding with the oil rigs, with the mountains, and my own observations. This effect changes in different conditions over long distances like this. So
yeah, but if the conditions are never beyond what the globe actually predicts, wouldn't you at some point in time be willing to accept that, you know what, we've made this measurement on multiple different days, in multiple different locations, all over the countries, hell, even in multiple countries. We went from the deserts of Arizona to the lush rainforests of the Appalachians. We went to the wintry hellhole of Canada. We've done this so many different ways.
Are you single and ready to mingle?
So when
hold on, bro, no,
sorry,
okay. I think doing all these is not a bad idea. Like, I think it's always good to do things. What I'm saying is my understanding is that they vary from a little more than 180 to some that are less. And then that's where you get into like either weighted averages and refraction effects. In terms of going to different places, I totally agree with you that it's very important to go to multiple places on Earth. Like, even if we show a curvature test or just any of these things, they all need to be tested on multiple places. You can't just take, I mean, technically, could you have just one flat area and the whole rest is curved under some wild concept? Maybe, I guess. You could have some actual flat area on a globe, but it couldn't be too big, but you could have some. But so yeah, either way though, this all needs to be done in multiple areas. So I agree with that. In terms of optical observations of mountains, well, that's what I was getting into too. Some areas are very consistently one way, like kind of distorted one way or another, and then some vary quite a bit. So I mean, if you're asking me if like going to 3 or 4 or even 5 locations from high mountaintops around the Earth, doing spherical excess with optics like this, or I mean, doing the spherical measurements like this, and if I was getting all more than 180 and I saw all of that from multiple positions, obviously that would be strong evidence to the phenomenon of observing that. What does it mean would be another question. But if that could be replicated to because right now there's not, like we've talked about, there's really no actual measurements of it. It's all weighted averages.
See, let me get in real quick.
Go ahead.
If things are getting magnified even slightly in the distance though, and you go to measure an angle between left to right and it's magnified, obviously it's going to be bigger than it actually is. So the bullshit spherical triangles don't really mean anything because you don't know where the light's actually going. You don't have any measurements of where the light's going. Like you just see light. You just see light. And that's all you know is that this is the angle the light entered your tool at. Like you don't know what path the light took or any of that. You've never measured it or anything.
So everything would be just, okay, so the light always takes the path regardless of the conditions, regardless of the location, to fool us into thinking that the Earth is round consistently without fail, regardless of the conditions. Okay, I got a bridge to sell you.
I don't think you're even getting the
Hold on, bro.
No.
You're a straw man and son. Hello? You're just a straw man and son of a bitch, aren't you? I never said that. I said that if things are getting magnified, obviously the angle is going to be more than 180. And they also measured angles less than 180 when they did the spherical excess measurement. So take that.
Cool. We should see it ourselves, shouldn't we? So let's do it.
See what?
So that's why I was asking if this would be enough. Obviously, the answer is no. We could have just had this conversation in 30 seconds by saying, you know what, Reds, I'm not even going to waste your time. Even if you took me to a bajillion different mountaintops and we took a bajillion different measurements, it wouldn't be satisfactory to me. That's all that needed to be said. Holy shit.
Yeah, that's what I was said to you.
That was Jeremy's.
I led with that.
Okay,
so
so
first thing said to you, Reds. This is so dishonest.
So at the end of the day, Gio, I'm assuming you're okay with them speaking for you. So at the end of the day, Gio, none of this would ever be sufficient for you.
No,
he told you what it proves.
Joke and say that was Jeremy's Joe Pesci impression.
Nothing is ever good enough.
That's what I was thinking of. I was trying to think of the actor. Sorry, my mind was in joke mode. No, dude, Jeremy. Well, I don't know. I guess he thought he's strong too, but it's all good.
All right.
What?
Jeremy thinks that nobody knows which way light's bending for some reason.
Yeah, Jeremy's making an argument saying that even though you have like those optical observations, if you haven't actually measured the way the light's bending, then it's assumptions and therefore it's not useful.
That's why we try to eliminate. Well, okay. The way that light typically bends in atmosphere is with atmospheric conditions. We know.
I'm going next.
That's why what we try to do is we try to eliminate that as a variable to the best of our abilities. So how do we get rid of that noise in the data? The way we do it in any other situation is we just get more data. We do this over and over and over and over again. Well, maybe this particular location is really fucked for some reason. Maybe there's always
the data proves the data.
Hold on, man. I'm going next,
data.
bro. I called it, dude. I called next after Red's done with his monologue.
Yeah, obviously these guys are in this. Let's obviously let them go. I was trying to.
No, that's fine. That's fine. My conversation was with you, and I think I got what I needed. So I'll just stop here.
No, dude, finish your point. Jeremy just wanted to respond. If you're asking me if these long distance, I have responded. Well, okay. Jeremy was responding though, or he wanted to go next. Do you want to finish your point though?
It's fine. It's fine. I'm good here. I think I got my answer. I'm fine.
All right. Well, but if you're gonna go to that, then at least let me respond. Okay. I would say, in my viewpoint, I don't think that long distance spherical excess observations from mountaintops is sufficient to be definitive for the shape of the Earth. Reasons being, yes, the refractive effects, the fact that it changes quite a bit. However, I also said if we went out to multiple places ourselves, we went to 3 sites, 4 sites, 5, 6, different continents, different parts of the world, different times a year, and we were always getting that effect. Like I said, that would be strong evidence that effect is a common occurrence. But what is the cause of it would be the next question. And that's why I think when Jeremy brought in the actual path of the light, that's what would actually need to be physically measured to delineate between shape of Earth and the path of the light that you're seeing when we're talking about optics like this. So that's the issue with it. Meaning that even if we showed for sure that it was always more than 180, even if we showed that, there's now 2 options. It's an optical effect in the medium, or it has to do with the shape of the Earth, or that the ground's curving, if that's the claim that the globe would be making. So that's why Jeremy, I think his point of saying like actually having to know which way the light is actually traveling and getting an actual measurement of that would be like the only way to delineate between those, because without that, it could be assumed that effect has to do with the ground curving rather than not, and that's all taking for granted that it is observably more than 180 consistently, which I haven't seen that validated yet either, and it really hasn't even been published, to like my satisfaction that is always happening. But but I do know it happens, and that's why I talked about all these the optical sort of dropping and the different positioning and magnification and all these effects that's why I went into all that. So that's kind of my response, at the overall thing. So would it be completely compelling to me? It would be in terms of that's an effect, but then the explanation for why the effect's happening is what we'd have to test next, and we have to test next anyways. So that's my soliloquy of my response to the whole thing, I suppose. But Jeremy, did you want to continue on what you were going to say?
No, then we just was about to go in some spiel about how he knows which way the light's going, even though it's never been measured. He's going to talk about refraction and it bends to the denser medium and this and that, like he knows what's going on. But it's never been measured, and B, it could be something other than refraction bending the light. Even in their own model, in the heliocentric model, they have things that aren't refraction that bends light. So that's not even a crazy idea.
That's your only argument, Jeremy. Like, come on, man. You got to.
Well, Gio told me.
You have 0 rebuttal to that, though. You got to come with a rebuttal, and then you might have something.
Progress.
Gio mentioned what it proves, and I thought it was really good. Like, it proves that that's what we observe. Doesn't prove anything else.
Oh, but it's okay.
It's a really important point. It's a really important point to understand.
Yeah, because B-Ball, let me say this. Hey, B-Ball, if we had can I interject? Okay, if we had a physical triangle on the ground, I mentioned earlier, one of the tests I want to do is just to let you know how much like these things are not finalized. Like when I've talked to people over the years, like there's many globe earthers that want to be on this research and actually doing it out in the field. So that just shows that like, anyways, I'm not saying it means they're on the fence, but I'm just saying like these are things that really haven't been done, and if they were done, there's higher levels of exclusivity. Because we're talking about optics trying to do spherical excess, and that is one thing, and that's why Jeremy's bringing it up, because it depends on light, the quote unquote travel of light, the medium, etc. That's the thing; it depends on that. However, if we had let me say this, hold on. If we had a physical triangle, okay, the way I've talked about doing it, you start with one small physical triangle, then you measure off from that one, you make a larger one, you measure off from that one, you make a larger one, all squaring it up perfectly as accurately as you can. You keep making larger and larger physical triangles on the Earth, and eventually you would start to get that excess effect if it was a globe. And dude, if we had that, now we're starting to get to some definitive evidence, some closer to definitive evidence that spherical excess is actually occurring on the ground, not just due to the optics. So I'm just trying to jump and say that if there was a physical triangle, I'm just saying that would get to a closer definitive, but the optics are problematic. Yes. I mean, if you're trying to try to say that this one optical, is enough for you, then I guess that's your choice. I mean, I guess definitive is going to be subjective to different people. I mean, if you think that's up to you.
Well, Gio, there's one way that we can verify, actually, because Jeremy wanted a rebuttal to what he just said. I'm about to provide one. Let's hypothetically say that we did this observation and we got measurements. Well, that means that we basically built a model of that particular area. So if the angles were consistent, then that means that we can go to that peak, and before we measure any angles, all we have to do is tell the telescope, hey, point to this peak, which, if our measurements are correct, should be this many degrees away. So if light was traveling in a straight line, that means the angles were consistent. That means that the telescope now has predictive capabilities within its electric motors that can measure angles very accurately. So if we go to a different peak and I say, okay, go ahead and point to the observer that's at that mountaintop, and it does it, and then I call you on the phone and I say, okay, I'm slewing the telescope to point at you based on our prediction of where it should be if light was going straight, and it does, and you see the laser pointed right at your eyeball, that would prove a few things. One, it would prove that our initial measurements were correct, and it would prove that light is traveling so consistently that it was able to make a prediction and hit you square in the eyeball based on that prediction. See what I mean?
Okay, no, that's not a rebuttal at all to what I said.
Okay.
I don't know what you're going to do with your telescope, whatever, at the top of the mountain. But if you point it at a place and you're saying this is the spot the thing is in, and it's a straight line because I can predict it, that's fucking worthless. That doesn't mean that's what it is just because you can predict it. If it's a consistent effect, of course you could predict it because it's a consistent effect.
So light would always be curving to the left, regardless if I do it from the north or the south?
If there's magnification happening, that angle would always be bigger because it's magnified.
You're not understanding. Okay, if I am dealing with an optical effect, and let's say that I'm looking directly north and south. If I'm looking from south to north, if we assume that the light is curving to the left, and that must mean from south to north, the light would be curving to the right, vice versa, that kind of thing.
I never said this is not any part of my argument at all, or anything to do with
obviously
anything I said,
it's not, because
I have no idea what you're even talking about right now.
It's a rebuttal.
Dude, obviously it wasn't part of your argument, because if it was part of your argument, you wouldn't have said the horse shit that you did. I'm rebutting.
This has nothing to do with anything I said.
Actually, it does.
This is not a
Actually,
rebuttal.
it does.
No,
you said that the light could be haphazardly going left or right or whatever the fuck. We can test that. Actually,
I didn't say that. Actually, I said if things are getting magnified in the distance, obviously the angle would be bigger than 180 because it's bigger. It's optically bigger.
Magnification doesn't matter.
So you're looking out optically. So you're looking out optically, and you're doing a left to right measurement. It's going to be bigger because it's getting magnified. Duh.
Okay, I cannot believe I have to break out the fucking crayons here. All right, I'm about to screen share something. Let's go ahead and do this. Okay.
Wait, left and right of what? North? Because isn't that a circle?
Hang on.
Yeah, I'm trying to. It's all good. We can just go through it one at a time. I'm trying to understand. What you made me think of, like a preferred direction of light and getting into like whether there's a clockwise, counterclockwise.
No, hang on. Gio, I'm gonna ask you a question here, and I'm screen sharing. If you can share my screen share. Okay.
Yeah. 1 second. You got to throw Coriolis in there. So. All right, go ahead.
Cool. All right, cool.
No, it's a Texas sharpshooter fallacy.
All right, so let's go ahead and look at this target. Okay, so right now, let me ask you a quick question. Gio, I know what the answer is, but I'm going to ask you just to physically do it. Can you identify the center of this target?
Let's say where the two black lines meet.
Okay, cool. So it's right here. So now what I'm going to do is I'm going to magnify it. Can you identify the center of this target?
Yep.
Go from the left side of the circle. Go all the way to the left side of the circle, and then go all the way to the right side of the circle.
Not done yet.
Then magnify it.
Not done yet.
Yeah, because by the way, I'm just giving general answers.
This doesn't have to do with anything I'm talking about. So,
for fuck's sake.
All right, but let's at least let him go through it because he's wanting to. And then, oh wait, you turned it off. What were you gonna?
Well, Jeremy keeps interrupting. I can't get a fucking word out.
You stopped talking, dude. I jumped in to say this doesn't have anything to do with what I was talking about.
I was waiting for Gio to respond. Weren't you the one talking about the rules?
I jumped in and
to talk over each other, and you're breaking your own rules.
I wasn't talking over anyone. I jumped in between you guys because I was trying to say something. It's not a break. I didn't break shit.
Yeah, you did.
It is Jeremy. It is Jeremy's argument.
I think Jeremy just said it didn't have to do with his argument. Maybe he wanted a rebuttal to his argument.
Yeah, they have no rebuttal to the thing I'm saying.
Well, hold on. Was this your rebuttal? He did kind of interrupt you though, but is this your rebuttal to Jeremy or is this a new thing? Let's just get
It's rebuttal to the concept that Jeremy was talking about, and I wanted to get an outside perspective, which is why I started talking to you.
Okay, so can you share it? Jeremy, can you oblige us in him going through that then if this is his response? I want at least to see.
Fine. I'll jump in after and show you why this has nothing to do with what I'm talking about. Go ahead.
You're talking about measuring the path of light in the physical world, geometrically?
Yeah, so I believe the argument was that magnification is somehow going to fuck up the path of light. Okay, let's assume for the sake of argument that that's true. That would mean that the mere fact that it gets fucked up means we cannot make any accurate or reliable predictions. So,
that's straw man. I don't know. I'm gonna go on mute or fucking something because I can't.
Dude, it's all good.
Straw man after straw man.
All right. Well, hold on, Rez. Maybe you want to finish.
At this point, I'm done. I'm done. It's like if I try to do a rebuttal, it's just going to be, oh, he's strawman me. No, the fuck I'm not. You just don't like the fact that your bullshit's being called out.
You're done.
Well,
like, holy shit. Because there are consequences to what Jeremy said. There are consequences to that. And those consequences can be empirically tested. And if I go out and I say, okay, if his consequences were true, if what he's saying was true, then I wouldn't be able to do this one thing. And if I'm able to do that thing, then that means his consequences weren't exactly influencing the original data point, because his consequences would corrode the accuracy of those exact same data points. How is this hard to figure out?
Well, let me. Okay, he dropped out. He might have been like stressed out at work or something right now. So let's just give him a break. He's got a lot going on probably. So, but he did drop out because he's a good guy, but he was getting a little heated. It's all good. So, atmospheric matter. Okay, this one I just posted here. This is again that same So, what do you think is happening here? Because I think generally what Jeremy might have been kind of was in my mind referring to, or at least I'll continue it at least, is that in like these two images right here, where one of them the water is like covering, like on the left the water is like covering the bottom of the legs of the oil rig on the left, and it's covering quite a bit of the one on the right. The one on the right is way lower. On the other one the oil rigs are about the same, and you seem to see the horizon is like beyond the second oil rig. So like the reason I bring this up, this does say atmospheric magnification on it, this little image, but obviously like that's an interpretation that somebody put on there. It could be debated what this is, but I think like if we're talking about that type of effect and it changing the physical position, then I think that's maybe what Jeremy's linking to, that the path of light is changing, or that's maybe even the argument I'm kind of adding in there. So I guess my question is like, what do you think of that? And then what do you think is happening in those two pictures? If it's not magnification, and then obviously one of those, like the one on the right pretty much looks like a flat earth. The one on the left could be interpreted as a globe because it's lower down, and somebody could think, oh, that's the tip of the ball right there where the water is. And then the one on the oil rig is lower, which would almost be like the idea of dropping over a curve. But then the other one looks flat and it's all flush and level. So like, what do you think is going on there? Because it's linked to the magnification and then ultimately the spherical excess or the path of light when it comes to like, these optical measurements and so on.
Well, again, we're talking about azimuths. Okay, so what we would expect to see if the rebuttal that Jeremy was giving was accurate? We would expect that platform to go from the right side of the front one to the left side of the front one. That's not happening. That platform is always going to be on the left side, i.e. the azimuths are going to be exactly the same. Now, let's say, for the sake of argument, that maybe there's some sideways refraction. Refraction decided that it was getting a bit Tokyo drifty on that particular day. Well, that's when we go ahead and we do more observations. That way we can clear out the noise in the data. So we do this over and over and over and over again. We do this for a week, 3 times a day, morning, noon, night. We do that to make sure that we have a nice spread. And if we did this only once, you would have reason to doubt. You would have absolutely reason to doubt. But if we did this multiple times a day in multiple different locations, probably over multiple times throughout the year, and we always get consistent results, we cannot say that side-to-side refraction is such, especially since we're doing it in multiple different directions, hence the triangle. Because one observer would be looking, let's say, I'm just going to pull a direction out of my ass, due north. Then a second observer would be looking the opposite of that. Then the third would be at an angle to those two. So we would have a nice spread of multiple different directions. And then we could switch it up. Okay, for this particular day, you go to this peak, you go to this peak, you go to this peak. We can switch the instruments around, thus making the data even cleaner still. We do all these things to try and make sure that the data that we're getting is clean of any noise. Because what you're worried about is, how do we eliminate noise to the point that any reasonable person would say that the data is clean? That's why I'm suggesting we do it in the way that we do it. But you're telling me that even if we do it in that way, you would still not be comfortable saying that that was enough.
That's because that's the criterion problem, right? They use the data to prove the data.
Fuck's sake. I don't even know.
Do you know what the criterion problem is?
I know I wasn't talking to you.
That's true.
So, Gio, would you please respond to what I just said, or did that throw off your train of thought?
No, it's all good. I'm listening. I heard everything. I mean, if you want to talk with Tor about that, that's fine too. Either way, but okay, my response though to what you said would be this. So I'm going to post this just one more time. I'm not trying to spam it, just so it's kind of in the feed since I'm referencing it. So like the oil rig on the right picture is like skinny, and the oil rig on the left is like fattened. It's like literally fatter. It's like wider. So that would throw off the azimuth right there. And if you want to call that sideways refraction, I guess we could, but I mean, it's like a bowing out effect. Like the actual width is actually different, like significantly, in terms of the pixels. Now this is claimed to be the same location, same elevation, but just different days. Obviously, it'd be good to always get, triple, quadruple checking of all these kinds of things. But I mean, there's a lot of other things like this. Now, the only reason I go back to this to respond is because I hear what you're saying. The thing is that, and that's why when Jeremy was mentioning like the path of light, I agree with him in that way, is that's obviously going to change and the only reason I'm going to this, like, I realize this is a different thing. This is low elevation down to the water observations over like a few miles, whereas what you're talking about is more like spherical excess from mountaintops. These are obviously different. There's different arguments for them too. Like some will claim that there's not the refraction at the high altitude, like people like Ruhif and others and so on. That's that there's much less to deal with and so on versus on the ground. Which I don't mention Ruhif for any specific reason. He popped in my mind. I'm not trying to quote him or anything in any particular way. But yeah, so like these observational effects, at high altitude versus low altitude are different. My only reason to go to the low altitude is right now is just to show the dramatic nature of it, and that the azimuth and zenith, like all of the angles are essentially can be skewed to a degree. And so that's where like the idea of the path of light, because if you have like the physical ground, like the ground is not changing, like unless anyone thinks like the ground is actually morphing. If we're staying in reality in that way, like the ground is there, it's there no matter what, but it's the medium. And if like on that image of the atmospheric magnification, like which one's true? Like is the level of the two matches the one on the left or the right? And then which is the true like curvature of the earth? Is it the one on the left or the right? You see what I mean? So that's why that image is so interesting. And it just brings in some of these optical effects. And I only bring that in ultimately to give you some thoughts or give you some of my thoughts about why I think some, these may not be definitive in terms of.
I understand that. And
Can I say something, Red? Can I say something, Red?
Well, that wasn't a response to him though. Can we let him respond?
But I mean, it's directly to this point, and it may lend to the conversation. If you're at observation, you're at point A, and you're looking at a mountaintop B and a mountaintop C. If you know the distance from B to C, you can predict what that angle should be straight up geometrically, and you measure it and see what you actually get, and that would probably confirm whether or not you've got any kind of magnification or distortion going on.
Yeah, and so to your point, Gio, you're like, okay, so which is the correct one, the left one or the right one or the top one or the bottom one, that kind of thing. I hear you. That's why I suggested we do this multiple times to make sure that the data we get is clean at the end of our analysis. Because if you were to only do this one day, we don't even know how much noise is in the data. We don't know how reliable it is. We don't know the quality of the data. And that's why we would need to do this over multiple different days, possibly even multiple different locations, possibly in multiple different countries. And if I was a very rich and generous person, I would be willing to pay so that we could travel to all of these extravagant locations with 5-star accommodations, of course, and do all of these measurements. And that way, at the end of the day, we gather all of this effort together in one spot and we analyze the data. And we know that because we did it over multiple different days, multiple times a day, multiple different locations, different times of year, yada, 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 blah, 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 we have filtered out enough noise to the point where the result would be conclusive. It would be satisfactory to you. And this all came down to a personal thing. And I was asking you a personal question. When would it be satisfactory? If the answer is never, no matter how many times we do this, and you would prefer it be done in a different way or whatever, that's fine, I guess. I don't agree with you, but that would be your position on it. But if your position is, hey, I appreciate all this effort, and I believe it would be valuable in terms of just having a conversation about it, but in terms of actually turning me to the dark side, so to speak, it would not be enough, okay, then it just wouldn't be enough. In which case, this would be wasted. This would all be a wasted effort, because if the whole idea is to turn you, for lack of a better term, this would not be the way to do that task.
Well, okay, so everybody else can give their comments too, obviously, so, if anyone else has thoughts on it too, because what we're basically talking about is like spherical excess measurements using, telescopes or theodolites or, long distance on mountaintops, and then getting these larger, like once you get 3 points that are far enough apart, the claim is that the angle starts to be larger than 180 degrees, in total. And the further the distance, the more spherical excess would be the case. So like 3 angles of a triangle always match up to 180. And the claim is that, if you have like 3 points define a plane, so a triangle defines a plane, like any 3 points define a plane. And so once you have 3 points, you can have a plane. And then that plane is would match to a planar Earth, and it would always just be 180. But on a globe, like it would start to kind of bow out basically as those 3 points are on a ball. And then you get more than 180. So now if that's what we're talking about, I would say in terms of like something being very, like for me, definitive, if we had the physical triangle one where we build physical triangles on the ground and that showed it, that would be compelling. Meaning, you get a small triangle, larger, keep making larger ones. Now, you're going to have some margin of error, obviously, like in making the larger triangle, of course. But if you started to get a consistent effect, like once the triangle were X distance away, and then the next bigger one, and it actually matched the curvature of the claimed globe, that would be getting pretty close to what could be definitive. Because now we're talking about something tangible, physical, on the ground, the margin of error is incorporated. And if you actually got it with a physical, tangible structure, that would be very strong. The optics are always going to probably be debated. Yeah. And for a lot of people, it may not be definitive to like what you're talking about, like flip someone or turn them or whatever, like on their view of the shape of the earth and so on. The optics seem to like strengthen people's arguments, but how often do they really shift someone fully? Because when you're dealing with like an optical spherical excess, I mean, if we went all around the world and we measured that ourselves, like you were saying, with tons of data points and the averages really were showing it, like I said earlier, I mean, that would be compelling evidence that effect is occurring. But then the question is, what is the cause of that effect? Is it because the ground's curving, or is it because the medium has a refractive effect? Would have to then be the next question. So in terms of like changing someone's view of the shape of the earth, wouldn't it have to go to that step before it could really be deciphered either way?
No, because we would have answered that question within the steps themselves. As I said, we eliminate that as a possibility, because if it was really the atmosphere, Well, we say, okay, if the atmosphere was wonky on this particular day, we'll do it in multiple different days. Well, if the atmosphere was wonky of that particular location, then we'll go into an entirely different location. And if the atmosphere was wonky during this particular time of year, then we'll do the observation at a different type of year. If we wanted to go to Colorado in the summer and then go to Colorado in the winter and then do it, and then go to Appalachian in the summer and then go to Appalachian in the winter and then go to Canada in the summer and in the winter and blah, 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 you get the idea. We basically can mix and match this 6 ways to Sunday until we're fucking sick of it. We're tired of airplane food, my guy. We are tired of getting molested by TSA, but we go through all that process. Even though we did everything in our power to make sure that the data is clean and when all is said and done, just the mere fact it's an optical thing is the big hang up for you. So when you say that the physical structure would be nice, the optics will never be.
Well, first of all, we'll be on a private jet, so we'll be
I don't know if I have that much money.
We'll be able to bypass the TSA, but to fly all over to do spherical excess measurements. Well, okay, so I mean, you're really trying to like pin me. That's fine though. You're trying to like pin me down on how compelling it would be and so on, or whether optics would ever be. Well, for example, let me say this real quick. What if there's an optical effect? What if there's like a lens effect to the environment, to the atmosphere, etc.? Whereas when you get far apart, there's like a warping effect because you're getting to like the extent of how far you can see, essentially. I'm not trying to put that forth as like a rebuttal or as a theory right now. I'm just saying if something like that was the case, I would be concerned that if I took, even if we had, like, I'm trying to like give you like that, let's say we went to all those sites and we really did find that, like, you know, that if we're at a closer 3 points, we just get 180, 180, 180. But once you go a little further 3 points, a little further, all of a sudden you're getting 180.1. Interesting. Then you start getting 180.2, 180.3. Like optically, that obviously would be compelling. I mean, that wouldn't, it's just, that would be random. You know, it's not just some random effect, like you were saying, like some wonky, just like some wind blew through. Like if you're getting a consistent effect like that, yeah, obviously that would have to be considered. And if it's accurate, if it's measured like that, to where then you get 180.4, 180.5, as you keep moving those 3 points further and further apart, it would obviously show that an effect is occurring that is matching that effect. I mean, if you're really able to measure it to that. So I mean, I wouldn't like deny that data if I was especially, you know, hypothetically primarily involved in it and doing it myself and so on. I'm not aware of that data existing, but yeah, go ahead.
Well, that's why we would get it ourselves. So the reason why I wanted to really harp on the lensing thing is that I said it can be tested. Now, I mentioned one way, and that was with the left and right thing, but let's ignore that for now. Lensing would require some sort of change to the apparent size of whatever mountaintop we happen to be looking at. Now, I'm going to assume, for the sake of argument, that we agree that topographical maps are accurate, at least good enough for our purposes, good enough so that hikers know where a particular rock is or where a particular summit is and that kind of thing, which means we have angular sizes to work with. If the angular size stays as it should be within our optics, then that would mean that lensing is not occurring. Lensing would impact the angular size explicitly. So if we're at all three mountaintops, I get, okay, I'm going to measure the angles to these other two observers, and they're going to do the exact same thing from their locations with their telescopes. Okay, they do that. Now I'm going to make a second measurement. I'm going to measure the angular size of a particular landmark. Oh, so on this side of the mountain, there's this little ridge. On this side of the mountain, there's this little boulder, and I can see it within my optics. I can then compare that to the measurements of topographical maps and do some trig. Okay, if there was no lensing effect whatsoever, it should be this angular size, which means that that span should occupy this many pixels within my optical train, within my camera. Oh, look, it does. We can now reject the idea that there is any lens happening whatsoever, because a lens that doesn't change the angular size of something is not a lens at all.
Well, okay, then what? I'm going to post it just one more time, just so for reference. But then why the angular size is different for the oil rig on the right on both images? The angular size of that oil rig on the right on both images is obviously dramatically different on the picture on the left versus the one on the right. So how could you only use angular size to determine? Are you using this to determine distance? You said?
No, I'm not. I'm not using it to determine distance. Okay.
Well, would you agree that the angular size changed here, even though the distance didn't change?
Yes, but I would also argue about their camera. I'm assuming this was done with either a Nikon P900 or a P1000.
I think these are Bose pictures. Yeah, like BLMSMB 6960. Yeah, that BLSMB. I forget the exact. I could.
Okay, so
but you know that channel.
And this is why I want to make this very, very explicit, is that depending on the movable lens of either the Nikon P900 or the P1000, which I have both at my disposal, it's very, very hard to get the same zoom on 2 different days, because that lens moves. And even though there is a digital indicator that will tell you roughly how many millimeters of focal length you can zoom to, that position is based on an electric motor. And that motor may not be accurate enough to get it at the exact same location every single time. That's problem number one. Now,
can I just interject really briefly? This is his channel. It's BMLSB69. I think I got it mostly right. But anyways, that's his channel. Right. I think it is a P900, but I'm not. I'd have to double check that though.
It's probably one of the two. But then the question then becomes, hey, why would that problem not exist for your scopes? Because my scopes do not have that type of movable lens apparatus. Once you assemble the optical train, you cannot change the focal length. They are locked together. So if you keep the same adapters and lenses and everything screwed together and that kind of thing, you will have the exact same focal length every single time. So let's say, for just the sake of argument, that you go up to the mountain, you make this measurement, and you see that the angular size does not match prediction. Ooh, that's a problem. And if that does happen, and if the lensing effect is such that we actually see that, then you would be totally justified in rejecting every single measurement that we make. But let's hypothetically say we don't see that, and the optical trains are locked, as I mentioned previously. We don't see that. We make our measurements of the angles. They are consistently over 180 degrees. Everything is pointing to a particular direction in this case. Would it then be satisfactory if we made that additional measurement with the angular size to make sure that there was no lensing effect happening?
Yeah, no, I hear what you're saying. Is the goal with the angular size, is that to evaluate distance? Or?
No, that's only to evaluate lensing. So if at a particular distance and a mountain is predicted to have a certain angular size, well, that's underneath the assumption that you're not looking at it through any sort of lens or whatever. So if I know what the span of my telescope's field of view is, I know what angular size fits into that optical train, I can then say, okay, then for each pixel that I'm seeing, it equals this amount of angular size. I can just count the pixels of how many pixels wide that object is. Now I know the angular size. So if the topographical maps make a prediction based on where you are, and that prediction turns out to actually be the case, that would only work if no lensing effect was even occurring. So no lensing is occurring. So we have eliminated lensing as a concern. It is not happening, which means we can trust our angle measurement, which will be a totally separate measurement. We would trust that, and then we would do it multiple times in a day, and then we would do it in multiple different locations, and then we would do it multiple times a year. Would it? No,
I got you, but that's why. But that's why I posted, like, I think Extra J, I think he just tagged you in it. I think he took one. He said both platforms have different angular sizes. And that's what I was saying. Now, this is down low to the water. You were mentioning a P900 effect. I mean, that all could be discussed. But I mean, obviously the angular like shape and size of that oil rig on the right does change. It's dramatically like warped. So when you're talking about like taking angular size like to a mountain, or I hear what you're saying, trying to like check that. Are you suggesting that when that's done, it always matches? Because I mean, in this case, obviously it wouldn't match. You know, unless there's some argument that this is like a unique situation, but there's a lot of other places on Earth where this occurs, where you get certain mountains that, like, in relation to mountain peaks, sometimes one that's further will look lower down, other time it looks higher up. And that's why I think, like, the one argument, I mentioned Xana because it really brings this one up a lot. And in my view, it's kind of like cherry picking it when the mountain looks like it's lower, like the whole Ranty photo with the Blackpool Tower and the mountain behind it. That to me is like a cherry pick. It's like one condition in which, yeah, that does match the rate of what the globe curve would be. Now, if that was always the case everywhere on Earth, that could be compelling, but it doesn't seem to be the case. It seems to be that it varies, and that now we have a refractive effect, which is even why a similar concept like where the horizon is and how much it's cutting off, even on a lot of the globe claims, is that it's a refracted horizon at this point. Like we're never actually seeing the curve; we're always seeing a refracted position of it.
Well, I'm just going to say this because I want other people to get in. I don't want to just hog everything. I have already agreed at the very beginning of this that the platforms have a different angular size. But if you remember, I had an explanation for that. It could be the case that the P1000 was at different levels of zoom, which would change the angular size. What I'm saying is that we wouldn't have that problem. We can guarantee that we were at the same level of zoom because our optics are physically locked together. You cannot change the focal length of our telescopes unless you completely rearrange the optics. So if we have our optics literally screwed together in the same order every single time, we can be confident that our focal length is the same every single time. I do not believe, even for a second, that was the case with the platforms, which perfectly explains why we're seeing two different angular sizes. So we wouldn't have that problem. He's most likely dealing with that problem with the P1000 or the P900 because I have a Nikon. I know its quarks, both of them actually, and it's very difficult to get that.
Yeah, I got you. No, that's an interesting rebuttal. For sure, like that it could have to do with that. I myself don't know that I know that we've studied these pictures quite considerably. I would have to pull up like the rest of them and kind of compare to figure out which ones these two are, of whether they are at a different zoom. The thing is though, I mean the water like on the left is like covering both of them, whereas the water on the right, like you know, is extended out. So I mean, whatever's happening, like even if someone said on the left, oh, that's the curve of the Earth right there, that's the water, the tip of the ball. Well, obviously the one on the right, the horizon, and that's the whole like black swan, what people refer to as black swan. You know, that whole argument too. But we're also talking about the position changing and the angular size. So there's a few things happening. The horizon looks like it's either further or beyond the oil rigs on the picture on the right, whereas on the left the horizon looks closer and it's like cutting off both of them. And then I hear what you're saying about the zoom thing. I'm not sure if it is different zoom or not because I know what you're saying. It could be a different zoom and then they just cropped it differently or whatever. Not sure on that, but and then also the oil rig on the right is higher or lower on both, and it's wider and fatter. So there's like multiple things going on in there. And so
this is why it would be imperative that we make these measurements multiple times, because you're right. There may be some atmospheric fuckery going on, which is why we would do everything in our power to make sure that the data is clean at the end of the day. And the only way that you're going to get a satisfactory answer is to do this over and over and over and over and over again. Now, I would argue that, and I'm going to use finger quotes here, I'm not saying this as a slight against you, but just let me get this out. Any reasonable person would probably be satisfied doing this over a week at the same location. A slightly less reasonable person would probably want it in 2 different locations. But I went way beyond that. I did multiple locations, multiple times of year, and even switching the order so that we do that same order again at a different time of year relative to each individual location. But it seems like that, again, would not be enough. It just wouldn't be. So if that's the case, and it would require us to literally build the greatest structure in flat Earth debunk history, and it would have to be something that you can physically touch and slap and that kind of thing, you know, maybe ride on like a little horsey or whatever the fuck, then I guess we're done, because I can't build that structure. I can't. I don't have enough money. I don't have enough materials, and I bet you I could not find people that would be willing to sell me their land to make that shit happen. Some of it is probably protected property, so we're fucked.
Yeah. Okay, so I hear you. Now, let me ask for you. No, because everyone may answer it differently. Like, what's, you know, that word definitive, like what's definitive or exclusive when we're talking about like the actual shape or the contour of the ground.
Well, I said
now for you doing these mountain peak long distance observations, if you said you've already done it multiple places, that's awesome. If you did it in even more and you were able to, that it's you're consistently getting greater than 180, what does that do for you? What does that conclude or resolve or answer for you in your viewpoint? And I'm just saying, if we take it, let's say it's all measured exactly like it said. Let's just say for the moment, like, because there's the whole thing of questioning whether you actually do measure this greater than 180, and especially having it be consistent with greater and greater distances, not just cherry pick locations. There may be some that are going to debate that, but even if for the moment we just accept that it is a thing, what does that do or conclude in your mind? Because like I said, to me, even if that was confirmed to be, it doesn't necessarily mean the ground is curving. It could have to do with the medium. And that's why Jeremy got into, you have to actually measure the path of light to confirm, is that light actually curving at the rate of a sphere, or is it actually not, essentially, and understand how that path of the light is actually comparing to the physical ground to know which one's which.
Well, no, I'm not saying that. What I'm saying is that if it were to change, we would know about it. And that way we can be very, very cautious, or we can say, hey, if we took measurements, we know for a fact that they're not reliable. So we would stop. We wouldn't even do the measurement. Why waste our time? We would go to Denny's. We would go to Waffle House. We'd spend our time doing something else.
Let me jump in
before
I lose it. Hold on. Let me jump in before I lose it. So, okay, I think I understand what you're saying. You're basically saying that, let's say you went out one day and you did the spherical excess, but you also do the angular size thing. And let's say one day you get 180 degrees and you don't get any crazy angular size warping or anything. Second day you do it again, you get 180. But then the third day you do it and you get 181, like 181. You're like, what is going on? And then you pull out you do the angular size and you're like, oh my God, it's a totally different angular size. Is that what you're kind of linking? Like the idea that like if there was something like that happening, it would be immediately linked or correlated with an angular size change. But that's kind of assuming that whatever the effect that's causing the 180 is also the effect that's linked to angular size. They may or may not be related.
We would disregard that particular day of measurement, but I would even go even further, because I am so confident that we will never see such a thing. I think such an idea is complete and total horseshit. That I would say that even if we saw it once, even once, I would say this entire methodology, no matter how many times we did it, no matter the locations we went to, it would not be good enough for me if we even saw it once. But since I'm so confident that we're not going to see such a lensing effect, we're not going to see such a dramatic shift in angular size as what would be required with a lensing effect, I'm not worried about it. So I'm willing to put that on the table. If we see any lensing effect in one instance, the entire methodology goes out the window. All the data is garbage. All the data is tainted. It will not be enough. It will never be enough. But since I am confident that won't happen, I'm willing to put that on the line.
All right. Well, I mean, you're okay? Well, I mean, I think the angular size of things does change. Like, there's all kinds of like warping effects that can happen, especially over long distance, at least to some extent.
Not to that extent. Not
But
to that.
either way, though,
the only way
that's
that
not necessarily directly linked to quote unquote like a lensing, that it would necessarily have to be related in that way. Meaning there could be an effect, a 3959 effect of like, let's say we see in a hemisphere, and as you get to the extent of it, you're actually picking up sort of like a meniscus, but it's a meniscus of the ether, of the atmosphere, not the ground.
Okay, but again, I don't know the mechanism of the imposed 3959 rather than just the geometry of our planet. If it's something beyond the geometry of our planet, I would need to know what that 3959 is in this particular framework. If one cannot be provided to me, I'm just going to say it's the geometry of our planet and move on with my day. But to this particular observation, and to the last point that I said, I'm willing to put that on the table. If we go out one day and the angular size is not what it is predicted to be, and that lensing effect is detectable, I would say the entire methodology can get thrown in the garbage. But I am very confident that Jeremy is wrong to suggest such a thing happens, especially to that extreme that it would totally fuck up our measurements, that I'm willing to stake the entire methodology on the line. I will sign my name to that. So if we go out and we do these sanity checks. Let's call them sanity checks. We know that our laser can match predictions. We know that the lensing effect is not happening. We can then be confident that when we do our azimuth measurements, they're actually measuring reality and not some distortions that are out there.
I want to quickly say something.
Go ahead.
Geo, you cannot introduce a radius, and I substantiate.
We have optics for that. Optics are much better than human eyesight. That's why glasses are a thing too. But keep this in mind that we're Carolina, not the beach.
Reasonable to say that optics are... Yeah, well, since we can't spot the geometric horizon with optics, and the horizon seems to depend on which optics you're using, it's not unreasonable to say that optics are a more viable explanation.
Well, again, we're not looking at the horizon. Doing this in the middle of the horizon, yes, if we really wanted to. But keep this in mind that we're not talking about doing this at the beach. We're talking about doing this on a mountaintop where the air is probably thinner, probably a lot colder, probably a lot drier than the beach. I'm talking about doing this in the middle of Colorado or the Appalachian Mountains in North Carolina, not the beach.
Yeah, well, since we can't spot the geometric horizon with optics, and the
middle horizon, and find my name to that. So if we go out and we do these not some distortions that are out.
The human eye. You got biology, you know what I'm saying? So what the gentleman is telling you is that...
Yeah, but the other side is saying everything is reducing to the limit of your vision.
We have optics for that. Optics are much better than human eyesight. That's why glasses are a thing too.
So we can use optics and spot the geometric horizon?
If we can use optics to spot a lot of things, which would include the horizon, yes, if we really wanted to. But keep this in mind that we're not talking about doing this at the beach. We're talking about doing this on a mountaintop where the air is probably thinner, probably a lot colder, probably a lot drier than the beach. I'm talking about doing this in the middle of Colorado or the Appalachian Mountains in North Carolina, not the beach.
Yeah, well, since we can't spot the geometric horizon with optics, and the horizon seems to depend on which optics you're using, it's not unreasonable to say that optics are a more viable explanation.
Well, again, we're not looking at the horizon.
Geometric horizon value.
Well, again, we're not looking at the horizon. We don't care about the horizon in this observation that we would be doing. We'd be looking at mountaintops. And if we have 3 observers at 3 different mountaintops, making mutual measurements of one another's location, we can get valid data off of that. And we can ask, okay, given the information that we got, given the measurements that we got, in the light of our sanity checks, of course, which model best comports with this data? We can ask ourselves that question. And I'm going to bet that the Glob would be the one that it comports to. Now, some people may not be satisfied with that for whatever reason. I think it's safe to say that Geo may not be satisfied with that. But if he ever does change his mind and he says, you know what, after thinking about it, there are enough checks, there's enough sanity checks, there's enough safeguards in place where we can be confident that the measurements are valid and that they would indicate something is actually the case, I'm willing to do this. I might be willing to squeeze some funds together and probably do some crazy shit.
How does it more comport with a globe if a globe requires a geometric horizon and we can't spot that with any optics? The apparent horizon just moves based on your optics that you're using, right? So that kind of more comports with the personal dome position.
The globe makes more predictions than just the horizon. Okay, yes, the globe makes a prediction that we'll even have a horizon, but we're not looking at the horizon for this. The globe makes other predictions, and one of the predictions that it makes is that if you were to do this particular type of observation, you would get angles more than 180 degrees. So if the globe makes that prediction and that's what we get, then it shows that the globe made a prediction and that prediction turned out to actually be the case. The horizon's irrelevant there.
Yeah, the horizons are relevant if you don't try and look for the geometric horizon. But if you do try and look for the geometric horizon, well, you can't spot it with any optics. All right, so that comports better with the personal dome of vision position.
The personal dome of vision is just some nonsense that Jeranism now has. Well, he came up with it originally. Jeranism did, and now he has disowned it as a concept.
It's not really nonsense. I mean, do you have a limit to how far you can see?
You're talking about the law perspective, right?
I'm asking, do you have a limit to how far you can see?
Yeah, it's the available resolution of your eye, but I have optics that can increase the available resolution available to me.
Right. Yeah, I didn't ask you that, but you have a limit to what your eye can see, right? So you have a personal dome of vision.
No, that's horseshit.
Yeah, every direction you look, that limit is going to make a dome of vision around you.
No,
right? You can extend it with instruments.
No.
And tools, yes.
No,
you just have a larger dome of vision.
No, you're wrong, because that dome of vision would indicate that there is a distance limit. I can see objects 5 feet in front of me. I can see objects 400 kilometers in front of me. I can see objects 93 million miles away from me. What dictates whether or not I can see it is the angular size and the available resolution of my eye. That's the only thing that matters when it comes to whether or not I can see it. It's not the distance. So saying that we have a dome of vision is literally nonsensical. Because I can see the space station with my naked eye. Now, I can't resolve any features, but I can sure as shit see it with my naked eye. And I've measured the altitude, size, and speed of the International Space Station. I know it's 400 kilometers up, which means I can definitely see something that's 400 kilometers away. Okay, well, can I see anything further? Yes, I can see the planet Mars. And I also personally measured the distance to Mars. I know that at the time that I measured it, it was 80 million kilometers away. Well, now the limits of my dome vision or whatever is now 80 million kilometers. But wait, I also measured the distance to the sun. That's 150 million kilometers away. So now I guess the limits of my vision are 150 million kilometers. Now the numbers are getting so big that it actually doesn't fucking matter what they are.
Yeah, I agree. The distance doesn't really matter, especially when you can't prove it, right? You haven't actually put a tape measure out and measured it, right? So things could be a lot smaller and a lot closer. You have no way to differentiate them.
We didn't use angular size to measure the distance. We used parallax, which cannot be fooled via the angular size of an object because we're not measuring that at that particular moment in time.
Parallax doesn't measure distance either.
Actually, it does.
Angles. No. You're measuring for the angle that's the parallax angle.
It actually does measure. No, angular size can measure distances if you know the baseline in which you made that measurement.
Yeah, but you said parallax, not angular size. You said parallax measures distances. That's not true.
No, it is. It is. It's alpha equals 2 times the arctan of g over 2r, and you simply rearrange to find r, which would be the distance to the object.
Okay, then you wouldn't be solving for the parallax angle. It's a different measurement.
No, parallax indicates that there is an angle at the very top of the triangle, which can also be the angular size of an object, but that's a different story for a different time. If I know that parallax angle given the baseline, I know how far away it needs to be in order for it to have that angle. It's literally just trig.
All right, but if you're, measuring the parallax, you're looking for the angle of parallax. You're
Yes.
not looking for a distance.
Yes, if you find the angle, you also found the distance as a consequence, because the angle that you measure is a consequence of its distance.
Is it?
Yes, it is. That's how perspective works.
So, I mean, but you can have the same angle of parallax and it'd be 2 inches or it'd be 2
No, you
miles.
can't.
Yes.
No, you can't. You would have
Yeah,
to
you can.
you would have
It's
to
called scale.
drastically no, you would have to
Have you heard of scale?
Nope. You would
You know
have
what's
to
scale?
nope, you would have to drastically change the baseline. If the baseline is consistent between two different measurements, I can tell you with 100%
What do you mean
certainty and
baseline?
confidence the distance between the two observers. Hold your finger out at arm's length.
The
Blink.
2 observers.
Yeah, that's how we measure parallax with 2 observers. There's 2 telescopes in that measurement. You didn't know that?
No, I didn't know that. There's 2 observers. Where are the 2 observers?
Spaced apart by some distance. That's the baseline that I was referring to. It would probably be easier if I brought up a diagram. Let me bring up a
So
diagram.
2 observers are involved in parallax measurement. So you can't make a parallax measurement by yourself, is what you're saying.
Correct. You can only make an angular size measurement. A parallax measurement would require 2 observers because it's the concept behind depth perception.
Well, it doesn't require 2 observers. It requires an observation.
Individuals here, and I see these stars. I see Mars right here, and I see those same exact stars. Okay, well, what happens if we overlay the coordinate data between the two? Oh, look, there's a shift. It changed. That's the parallels.
This is from?
That we trig. Now you ask where e equals 22.
Back to the parallax angle because you said
Okay, let's
from the
go back to
parallax
that
angle
video.
alone you can't get any distance, and that was the whole argument.
No, you can, because you can go further than
Without
just looking at the
assuming-
parallax value. A
Without
parallax
assuming
value
distances
has a
or
consequence.
variables.
So
Can you
if
go
you
back to
know,
that?
so if you know if you know the parallax given the baseline, you know the distance.
If you know the parallax, so once
we
you
do.
measure the parallax angle,
Which we do.
and then if you assume a baseline,
No,
you
a
can
measurement,
we
not
said if
assumption.
you know the baseline, okay, then where did you measure the baseline?
Okay, good question. So what we did was we measured the radius of the Earth, which is this part of the video. Then we figured out exactly where we were on that planet. Let me
That's what I'm
find
saying. You need to know or assume
up.
the radius
Hang on,
and size
hang on.
of the Earth.
You have
said
to
that
let me.
was wrong.
You have to let me finish. Again, we already figured out the size of the Earth at the beginning of the video. We already established that. That's done.
What?
That's dusted. So
how is that
if-
tested? How is that established?
So given the fact that we now know
Wait.
for a fact the radius of the Earth, i.e. the size of the Earth, we figured out the size of the Earth at the beginning of the video. We already established that. That's done.
What?
That's dusted. So
how is that
if-
tested? How is that established?
So given E, and if I know angle E and I know the radius, I can find the baseline because that's just an isosceles triangle, my guy.
Are you trying to explain it to me? Because I'm asking you questions and you're just talking.
Well,
over
in order for you to actually learn, you have to listen to my entire answer and not just interrupt
okay,
me.
but you're
halfway
jumping
through.
all around. It's very disjointed.
No, I'm actually
and not
staying on
very
point.
coherent.
No, I'm actually staying on point.
Yeah, you're skipping over the relied upon assumption. So that's what I'm trying to get at.
Well, there was no relied upon assumptions, and if you had
Well, you
listened,
said
you
you
would have
already
realized
figured
I'm
out
not
the
attention.
radius of the Earth in the beginning of the video. How did that happen?
So what I did, once again, was we looked at the North Celestial Pole. You see this telescope right here. This telescope has very accurate motors within it, and these motors can report back to me what the altitude angle is. Okay? So how accurate are these motors? Skip that again. God damn it.
Wait, do these motors, do they have the Earth size assumptions already baked in or no?
Nope, they were just measuring angles. So then
It's just
we
angles.
have 3 miles. We drove 3 miles. We take a second 0.11. Hang on. Time. Nice. That's how we got the size of the Earth.
So we got the 2 angles, elevation angle measurements, right? 3
Mhm.
miles apart.
Uh-huh.
And that's all you need to get 3967, I guess.
Yep, there's the math right there. Right there for you. So now that we have that, we can then say, okay, given that we know the size and change the answer, because if we drove further, baseline literally determines
the level of accuracy.
that was important to us.
You don't even know
if you're going north to south or along the equator. There's a bit of a that was important. You say 3959 is what should be. Well, one, I assume you already know that that's just an average. In fact, the distance is different if you're going north to south or along the equator. There's a bit of a bulge there. You may know this from Neil deGrasse Tyson and the pear-shaped bullshit that you guys like to go about. So you know that it's not a consistent measurement all the way around. That's point number one. Point number two is that we want 3967 is correct. What is the angle of our baseline? The stars. The angle between those stars is, if I know, so it'd be a single E. He can find angle A, which is the angle. So I plotted my points in 3 M. X is 80 million
of your vision. Well, optics, how far you can see in
183.6 to find length X. And finding length X is the distance between Astronomy Live and Mars. And when we do, we find that...
What, the personal limit of your vision? How far you can see in any direction?
Yeah, because apparently it's not 80 million kilometers, so what is it?
Well, I mean, it's going to be atmospheric conditions and what optics you're using.
Okay.
But still... it to me, because like I'm asking you questions and you're just talking.
Well, in order for you to actually learn, you have to listen to my entire answer and not just interrupt me.
Okay, but you're jumping all around. It's like very disjointed.
No, I'm actually staying on point. No, I'm actually staying on point.
Yeah, you're skipping over the relied upon assumptions. So that's what I'm trying to get at.
Well, there was no relied upon assumptions, and if you had
Well,
listened,
you said
you
you
would have
already
realized
figured
you're
out
not
the
attention.
radius of the Earth in the beginning of the video. How did that happen?
Dude, what it would have to be, imagine you're in a hallway and you're walking down the hallway and there's a sharp right turn. You know, so you're going down and there's a sharp right angle where you can either turn right or you can go straight. So what it would have to be is, imagine you're just walking straight, you have not reached the right turn yet. You're getting close to the right turn, but not quite. You're still a couple feet around the corner. And then somehow you have to be able to look at the corner, and the entire hallway behind it has to be like moved in its position. Like, it can't be to the right anymore. It has to straighten out and almost look like it's straight. Because that's what's happening with the Globe claim. Like, they're like, oh, you're on a ball. They claim that you're looking over the curve. But in these conditions where you can see way past the geometric horizon, you see this horizon, lifted up and it's all extended out, level, horizontal, all of that, like a plane, as a planar Earth would, is what you actually see. So what's happening is that all that curved land that's supposedly going down around the curve of the ball is actually like extended, like lifted out, as if you flattened it and lifted it and made it all look straight and planar. So that's what I was saying, in the corner of the hallway, that would be like akin to, you're going down the hall, you haven't turned right yet, you get close to the corner, and then you look at the corner and the whole hallway is like it looks straight to you, as if you were just to keep walking straight. So that's what I was saying, in the corner of the hallway, that would be like akin to, you're going down the hall, you haven't turned right yet, you get close to the corner, and then you look at the corner and the whole hallway is like it looks straight to you, as if you were just to keep walking straight.
So here's the best example.
The Earth is flattening out and looking straight, even though it's supposed to be curved.
What, hey, Jay, the sunset? What's your name again? RG, right?
Oh, yeah. Yes, sir. Yeah.
So what I believe that phenomena, what I believe is actually happening, is that darkness is actually a thing. It's not the absence of light. I think the darkness is coming. The darkness is following the light. And these two things are actual things within themselves. It's not the absence of light, therefore darkness. No, you have darkness, which is the opposite to the sun, and the darkness is following the light.
I mean, I guess I think, honestly, I think it's the black in our eye, like the darkness.
The sun's light doesn't act any more. You
can replicate in some ways, not really fully, but
I can just use it and just create like a shadow wherever I point it. Right, the darkness is a thing.
Talking about the luminaries and the sky, it's nothing that you can replicate down here in the lab.
Well, there is the sonoluminescence, the star in a jar.
Of course you can.
She kind of can replicate in some ways, not really fully, but. You guys saw the horizon, or is this a different topic? I was maybe away from it.
Hold on, are we talking about a dark light here where you turn on like a dark sucker or something?
Like Rahu. They don't believe that either.
Let's have something against the second law of thermodynamics, along with cold moonlight.
Are you guys on eclipses now?
No, they're on dark. You don't understand how light works. They think that dark is a thing. So we have dark suckers now.
Yeah, that's actually an interesting idea, that darkness is actually like an entity in a way. Or like the idea that the night sky is, well, okay, I don't know exactly what you guys are on, but it would be the idea that like the blue sky is like a luminary in a sense, and then the dark sky is actually a luminary as well. So you get this yin yang, like that the darkness, it's not just the absence of the sun looking off into space, but the darkness is actually like a luminary of sorts that actually like polarizes the sky and is its own actual sort of entity in the sky, as it were, just like the blue
There's a
sky.
great book, JL, called Orion in the Dark, which kind of explores that idea. It's like a kid's book, and it's got a cartoon also that they made. It's basically like that, like darkness is its own entity, and it sweeps over the land after the sun, after the light is done, and brings on the veil of darkness.
Yeah, if you know Kevin, or like
So-
Kevin 7 or Kevin 7, if you know him on here, he did a whole presentation on here. Was going through the Quran and how the Quran actually indicates that darkness is its own. It's like the darkness envelops the day, and the day envelops the night. And there's this, and it actually explains some of the observations that people say are problematic on a plane. If darkness is actually its own effect that can essentially like block the sun, but that's a more nuanced kind of part of it. But yeah, go ahead, left lane.
Yeah. Go ahead. You're breaking up a little bit.
Oh yeah, you're breaking up a little now. I was trying to let him in because he was trying to get in.
I got you. What do y'all think about like during the day? You know how the pupil closes up to a very, very small hole,